Hello students, good morning everyone. I hope you are getting my voice clearly. Good afternoon guys, good afternoon. Are you getting my voice? Just to drop me a message. Can someone drop me a message or not? Can someone drop me a message in the chat box? Right. Yeah, so as in the previous session, we have already we have completed the weekend portion, and now just let us try to work out few numericals, guys. Let's try to work out few numericals. Right. So in level 2, exercise 2, some of you has pointed out a doubt, right? So question number 19 in level 2, exercise 2. So let us start with that. Then we'll work out the other questions also. So question number 19 in level 2, exercise 2. Question number 19. So level 2, exercise 2. Level 2, exercise 2. So the question is, a wire of length L and cross-section area A is suspended at one end from a ceiling. The strain energy due to its own weight, if its Young's modulus is Y and density is D, is within bracket it is given that G small g is equal to acceleration due to gravity. Options are given as first option. Okay, let me read the options. First option is d square g square a l cube by 6y. Second option dg a l cube by 6y. Third option d square g square a l cube by 3y. And fourth option d square g square a square l cube by 3y. Right. Let us try to understand how to work out this kind of questions. So you need, yeah, you should remember the derivation part of the energy stored part. With the help of those steps, we can understand this. Right. So first, let us consider. It is given that as per the question, it is given that a wire of length L. Once again, guys, I hope you are getting my voice clearly. Are you feeling the voice is? If you are feeling, if any of you are feeling, if the voice is low, please drop me a message so that I can make it little. Yes, no. Harini, your voice is clear, sir. Okay, thank you so much. Thank you so much. Are you getting the voice loud enough? Are you getting the voice loud enough? So if you drop a message in the chat box, then I can refer it. During the session time, I may not open the WhatsApp. So if you drop a message in the chat box, I can immediately I can go through that. Right, okay. So it is given that a wire of length L and cross-sectional area A is suspended at one end from a ceiling. Let us consider this is ceiling of, okay, this is ceiling, and a wire of length L is suspended from this. It's clear and loud. Yes, thank you so much. Thank you so much. It's clear and loud. Okay, fine. Yeah. So a wire, let's get into the question. A wire of length L and cross-sectional area A is suspended at one end from the ceiling. The strain energy due to its own weight. The strain energy due to its own weight. If its Young's modulus is Y and density is D is. The strain energy is also called as elastic potential energy, right? To understand this, let us consider. Um, we have. I hope if you remember the derivation part, we have considered. We have considered a small element of length dx at a distance x from the free end, right? So as it is having a mass m due to its own weight, where this is not the derivation of what you call strain energy, the breaking of a wire due to its own weight. While discussing about that, we have followed this procedure, elements, what you call differential elements method, that we have to apply to this one now. So if you consider a small element of length dx at a distance y from the free end, usually if there is usually here a force will be acting due to its entire weight. If you consider this at this point, what is the force on this? So that, and due to elongation of this, what should be the work done to be required to be done on this, so that will be stored as energy. uh, 1 second, I'm getting more volume here. Let me reduce it. Right. So what you have to consider here is, let us say a small amount of work done somewhere. Let us consider a small element dx at a distance x from here to elongate this to, and at this distance, let us say we have to do a small amount of work done. That will be stored as a small amount of energy. So we know the elastic potential energy is nothing but half into stress into strain into volume into volume. Yep. Of into volume. So let us say the strain energy in doing so for this element is half into, usually stress is nothing but force by area, strain is nothing but elongation by length, elongation by length. Let us say, let us consider here the elongation of this smaller element, the strain can be taken as dx by its horizontal length. Actually I have to take here, if you want in terms of, here if you observe the options are in terms of Young's modulus, right? So you have to replace this in terms of Young's modulus, and density and g also should be there. That means you should have force, and that means stress. So you have to replace the strain with stress and Young's modulus. So again here, as we know, Young's modulus is equal to stress by strain. You can write strain from this is equal to stress by y. So if you replace this with the stress by y again, so again you will get stress by y, f by a into 1 by y into volume. Volume can be expressed as a into volume of this element. This you have to consider. This is x. So now, if you further simplify this, of course, one a you can cancel it out. Hmm? This is, yeah, stress by y, and so 1a can cancel here, then it becomes is equal to half into f square by a into 1 by y into x. Actually, yeah. So what we are doing here? Volume of small element we have to consider. So you have to take it as a volume of the small element will be A into dx. This will be the dx. So now we can take this as into dx. This further you can take it as a half into f can be taken here as you have to understand this what you call this a side working out steps a little carefully guys. Force can be taken as a weight. Weight is nothing but mg. The weight acting on this will be equal to, and that elemental volume is elemental part is equal to differential element is equal to mass is equal to density into volume into g, density into volume into g. Here this further can be taken as density into volume of the element which is exerting force on this will be this one. If you consider its volume is area into its height as x, then you can take it as a d into a into x into g. This is f. As it is f square, we can write this as half into f square means d square a square g square x square by a. This is f square by a into 1 by a, or you can write it as a into y into dx. This is the small amount of energy, a small amount of work done that will be storing as strain energy in stretching this wire by a small amount at a distance x. So here if you observe again, here a square is there, here a is there, this you cancel out, you get only one a here. Therefore this will be equal to du is equal to you can write it as a d square g square a by y, 2 is here 2y into x square is a variable. X will change if you are going from here to here or here to here. So from 0 to if you go here, the x becomes L. So you can write it as integral of x square dx, where x goes from 0 to L. So this further you can write it as this is equal to d square. This actually what we are doing is, this is a small amount of energy. If you want the total energy, you have to integrate this, the total energy stored, a total energy, a total work done. If you want to, you have to integrate this. On integrating, you will get as a d, a, g, r, and y are constants. So by taking them out, d square, g square a by 2y into this x integral of x cube dx becomes x square dx becomes x cube by 3, x cube by 3 with limits 0 to L. So x cube becomes, on substituting this L, it becomes L cube. So therefore we get here 3, if it comes here it becomes 6y. So therefore total integral of du gives you the total energy. It is equal to d square g square a L cube by 6y. This will be, this will be the energy stored. Actually this is the work done in work done uh, work done acting on the wire in stretching it due to its own weight, or you can also say it is the strain energy stored in the wire in producing some strain due to its own weight is nothing but d square g square a l cube by 6y. So option 1 is the right one for this one. I hope you guys have understood this. Right, next let us see question number question number 20. Question number 20. Let's copy this, everyone copy it. So the right hand side steps you guys have to copy this carefully. Then these things will become a little more easy. Okay, here you can, then again here you can write advice if you want within bracket, because f is equal to, so this one f is equal to density into a volume is area into x into g. So because of this we are substituting here, then you will get this step, and you can simplify further. These points you have to remember carefully guys. Note down this, note down. These, especially in competitive point of view, this differential element method based simplification points are very, very important. Number of times, in number of chapters, different chapters in 11th standard, like in gravitation, and even in what do you call it, well, calculating center of mass in rotational motion or system of particles, and even work per energy, In different chapters we'll come across, and even in 12th standard also, this method, differential elements method, will be used in so many different chapters. You guys have to remember this, right? In practice, then only you'll remember, right? Next one. Let us see next question number 20. Question number 20. So what is given here and what we are asked to find? A wire of length L and cross-sectional area A, sorry, 20th question, right? Two wires of same material and same diameter have lengths in the ratio 2 is to 5. They are stretched by the same force. The ratio of work done in stretching them is. The ratio of work done in stretching them is. Ratio of work done means you can say the ratio of energy stored. So yes, how to consider this? First, write down what is given here. It is given that two wires are there of same material and same diameter. Two wires are there, wire 1 and wire 2. They are made of same material. Same material means y1 is equal to y2. In previous sessions also I have discussed this point. Should be equal to y, and there should have, and in this case they have same diameter. Means d1 is equal to d2 is equal to d, let us say, and hence radius. Diameter is same means of course radius also should be same. Means area also should be same. This same means you have to understand the diameter or radius are same means you have to say a1 is equal to a2 is equal to a. Area of both wires are same. Area of cross section of both wires are same. And two wires of same material and same diameter have lengths in the ratio 2 is to 5. So L1 by L2 is equal to 2 is to 5 means 2 by 5. 2 by 5. They are stretched by same force. Again, one more data is given here is, say the stretched by same force means force acting on both. F1 is equal to F2 is equal to F. Let us say same force is acting on them. Then ratio of work done in stretching them is ratio of work done. Then what is the ratio of work done? W1 by W2 is equal to what? So which relation you have to use? Which relation you have to use? You know that work done is nothing but energy, elastic potential energy. Elastic potential energy. We know that work done. Just I may be giving every point here for understanding purpose, and I may be giving step by step clearly. So I may take more time. Guys, do you guys after understanding? We have to practice in a very short time, guys. Okay, you have to practice minimum 3 times. So to improve your timing, we know that work done in stretching a wire will store as restore restore as strain energy, strain energy or elastic potential energy, right? So as we know, elastic potential energy or strain energy or work done in stretching a wire is W is nothing but elastic potential energy is equal to half into stress into strain into volume. So this is equal to half into stress is given by generally F by A. Strain is nothing but actually you can write it as delta L by L. But here if you observe what we are doing, which question number 20. So it is given that both are having say both are made of same material and same diameter, etc., etc. They have given means same material means Young's modulus will be same. So in terms of Young's modulus, but if you express, then it is easy to understand this. So let us express either in terms of stress or in terms of strain. So force is given, right? So let us try to express it this in terms of stress only. So this can be expressed as half into strain is nothing but stress by y. So it can be expressed as stress into stress by y becomes stress half into stress square by y into volume, right? So this is here I have to write this one. Now this step you can write it as is equal to half into stress is force by area. So F by A whole square means F square by a square into y into volume. Volume is nothing but area into length. Right here, 1a will cancel, and hence you will get is equal to half f square L by a into y. And again, if you look at the given conditions, same force acts are having same diameter means same area, both are made of same material, and lengths are in the ratio, some ratio. That means you can say this work done or energy stored is directly proportional to L. So from this we can say that this implies work done is directly proportional to L. So therefore, and this implies W1 by W2 is equal to L1 by L2. Yes, very simple, right? Is it a direct relation? So lengths are in the ratio of what? Lengths are in the ratio of what? 2 is to 5. So this also becomes 2 by 5. That's so work done also will be in the same ratio, 2 by 5 only. That's it, very simple. This is your answer. Right, note down guys this one, right down. So some people have joined now. Just you guys can go through now from the starting. Read the question. This is level 2 exercise 2 question number 20. Level 2 exercise 2. Level 2 exercise 2. Level 2 exercise 2 question number 20. Level 2 exercise 2 question number 20. Right. Next. Yeah. Let's see next question number 21. Next question number 21. Right, question number 21. So what is given here and what you are asked to find? Again, level 2 exercise 2. Level 2 exercise 2. If anyone joins in between, they have to understand this. This is belongs to level 2 exercise 2 question number 21. So it is given that a wire fixed at upper end stretches by a length L by applying a force F. The work done in stretching is a wire fixed at the upper end. There is a wire whose one end is fixed, that is upper end is fixed, and let us say at rigid support, and the lower end is free, right? The wire is fixed at the upper end, it stretches by length L by applying a force. Means say at lower end, the force F is applied. As a result, its length is increased by L. So let us say initial length is capital L, and increase in length is small l. Increase in length is small l. This is a wire fixed at upper end stretches by length L by applying a force F. Now the work done in stretching is, what is the work done in stretching? What is the work done? Work done in stretching is nothing but the word energy stored. What is work done? What is work done? This we know is nothing but elastic potential energy or strain energy is equal to, same thing we can put it as half into stress into strain into volume. But here again, based on the options, you have to simplify. If the options are in terms of Young's modulus, you have to take Young's modulus and force. You have to take in terms of stress and Young's modulus, and elongation and Young's modulus. You have to take in terms of strain and Young's modulus. Otherwise, if they are in terms of force and elongation, like this kind of terms, you have to keep stress and strain as it is. This you have to understand while simplifying. So you may ask, how can you understand why we have to keep in this form or this form or this form? By looking at the options, you have to work out. So already a number of times I have repeated to you guys. Yes, we have to work out by looking at the options only, right? Right. So now, as in the options are mentioned in terms of F and L. L is extension, F is force. It means stress should be there, strain also should be there. So if you simplify this further, then we can write it as half into stress can be taken as what? Force by area. Strain is nothing but change in length by original length. Change in length is here is given as a small l. Original length is given as capital L. Change in length is small l. Original length capital L into the strain into volume. Volume of the wire can be taken as A into L. Volume of this wire is A into L. So here A cancel, L cancel. So work done in stretching the wire by length L, small l is nothing but half into F into L. This we can take it as delta. We have taken delta L, or if you take it as delta L, F into delta L. If you take this extension is E small e, then you can take it as half into F into small e. Any of the forms you can take. But here this extension extended length is given as this. So accordingly, I have to take this. That's it. So half into F into small l. Extended length. Which option is right? FL by 2 half into F into L or FL by 2? Option 4. Question number 21, option 4. Option 4. Note down this. Right, next. Right, next. This question number, let's see, question number 22. So what is given here in 22nd question? Question number 22. Next, question number 22. So what is given here is given that if S is stress and Y is Young's modulus of material of wire, the energy stored in the wire per unit volume. This is a direct formula, guys. So what's your answer? Can you just drop me a message for this? Those who are now online, can you drop the message? What should be your answer for question number 22? Level 2, exercise 2. Question number 22 is a direct question, guys. Formula based one. Can you drop your option? What is your option? Drop me your answer. Drop me your answer. Drop your answer in the chat box, guys. Drop your answer in the chat box. Yes. Yes, Kanish. Yes, 2 by 2y. Okay, no, no. You can drop the option. Just no need to give the expression. Option. Option. What is it? S square. S square by 2y. Which option? Option 3. Option 3. Others? Very good, very good, Kanish. Don't feel bad in responding, guys. Don't feel bad. This will be kind of communication, conversating session. Okay, can involve you can involve in the discussion. Don't think that if you are so matured, you will not respond. I think this kind of things don't keep guys. Okay. Yeah, yeah. So very nice, guys. Right. Next, let's go ahead. Next question. So question number 22. I don't think you need to work it out. So what is it? It is a direct formula. What is that? If S is stress Y is Young's modulus of material of a wire. Energy stored in the wire per unit volume. Energy stored per unit volume. U by V is also called as what? Energy density. Sometimes we will be asked with this term also. Energy density we can call it as energy density. So you may ask what should be the energy density in the wire also. Energy density is nothing but half into stress into strain. Different other forms of this we have discussed already. You guys have to remember those. So that is in terms of stress and Young's modulus. You can write it as half into strain. You can be replaced with stress by y. So because y is equal to stress by strain. You can write strain if you bring it here. We can write it as stress by y, and hence it becomes stress square by y. Or you can also write it as in terms of strain. Stress can be expressed as y into strain. So strain into strain becomes strain square half into y into strain square also you can write. So stress square by y can be expressed as here it is equal to here if s is stress and y is Young's modulus, then it becomes half into s square by y or s square by 2y. And if a strain is given some sigma, then half into y into sigma square, like that you have to write it. So that's it. That's why it is mentioned as a direct formula. You have to just keep in mind these different relations. Right, it is energy per unit volume. Volume is here. Otherwise, the only energy in terms of this, if you ask, we have to multiply this with all these parameters or expressions with volume. That's it. Then next question. So this is our answer. This is our answer. Okay. Right. Next. Is question number next 23. Question number 23. Question number 23. So what is given here and what you are asked to find? Yes. So what is given here? A simple pendulum is made by attaching 1 kg bob to 5 meter long copper wire of diameter 0.08 centimeters. And it has a certain period of oscillation. A certain period of oscillation. It is still T. Initial time T1 equal to T. And if 10 kg bob is replaced by 1 kg, actually replace earlier we have 1 kg bob. If 10 kg bob replaces 1 kg bob, not 10 kg replaced by 1 kg is a kind of what you call replaced by 10 kg bob, or if 10 kg bob replaces 1 kg bob, then the change in time period is what? Right, let us try to understand this one. So we already discussed this kind of questions also, right? What you call comparison of what you call pendulum or the spring mass system, etc. So but the spring mass system comparison we have discussed the time period of spring comparing this time period of spring mass system as 2 pi to 10 by m by k in terms of k spring constant. In terms of simple pendulum, if you want to compare, you have to remember that if you have a simple pendulum of bob having some mass m, then if it is mass m, then its time period is given by t is equal to 2 pi into square root of, if its length, effective length is l, then it is 2 pi into root l by g. 2 pi into root l by g is time period. Now in this case, the simple pendulum made by attaching 1 kg bob to a 5 meter long wire. Oh, here it is initial length is given as L is equal to 5 meter long wire. 5 meter long wire. If M1 mass of M1 is equal to 1 kg bob is attached to this length of 5 meter, then initial time period of the time simple pendulum is given as T1 is equal to, it is a certain time period. Let us take it as time period T. Now, if the 10 kg bob replaces 1 kg bob, that is if m2 is equal to 10 kg, the length is same only, l is equal to l2 is equal to 5 meter only, then what should be time period, and hence change in time period delta t is equal to t2 minus t1 is equal to what is the question, provided Young's modulus is given here. Young's modulus, so you have to make use of Young's modulus in calculating this. Young's modulus of the material of the wire. Wire is made of what? It's a copper wire. So a wire is made of copper. So it is a copper wire. So Young's modulus of the copper wire is given Newton per meter square or Pascal. It is a unit. So then how to find this? How to find this? You have to, as we have discussed there, you should remember what is time period. Now we can say, as uh, when mass increases, what happens? Force increases here. Because of this mass there will be a force. F is equal to mg. As mass increases 1 kg, if you replace with the 10 kg, mass increases, so force increases, so the extension length will increase, right? So here this is effective length. Effective length will changes. Effective length changes to this initial length plus some change in length delta L, it will become. That you have to understand carefully. Now let us say T1 is equal to, let us keep this as 2 pi into root L by G. Let us say this is equation 1. T2 equal to what? T2 T2 is equal to 2 pi into square root of L2 by G, can be taken as L2 is nothing but L plus some L1 is L plus some increase in length by G. Got it? This further you can also express as, this is equal to 2 pi into square root of, let us take L out, then you can write it as L by G into 1 plus delta L by L, it becomes under root. These steps you have to follow carefully. But here delta L by L, but here Young's modulus is given, masses are given, this and that, those are given. How to make use of these things in understanding this is, let us also take the expression of what? Young's modulus expression. Young's modulus expression from the delta L by L is what? We know Young's modulus y is equal to FL by A into delta L. From this, if you bring it here, it becomes delta L by L. If you bring it here, delta L by L, F here only, y will come here, it becomes F by A to y. So this implies delta L by L is equal to A into y. F is nothing but the load, right? Here, the load can be taken as what? mg. mg by area can be taken as a only. No, is there anything explicit about the radius and all? So radius and all, yes, something else is given in terms of this. So we can keep this area like this only, um, a into y only. Right, if you take this as delta L by L here, sorry, here you can write, because the delta L by L is this. If you take this over here, what else you can take this? So to find this change, you can write this as T2 is equal to 2 pi into square root of L by G into 1 plus delta L by L is mg by A into y. A into yes, A into y, right, under root, that's under root. So now you are at this T2, this is T1, right? Let us take this as equation 2. Now as you are asked to find T2 minus T1, changing time period, how to do this? Delta T is equal to T2 minus T1 is equal to, some terms we can keep common, 2 pi here, 2 pi and 2 pi common, here root L by G is there. Here also if you make root L by G common, then you can write it as root L by G into root of this one, so you can write it as 2 pi root L by G out, then you can write it as what you can write, what you can take this as, if you take this out, T2 minus T1, in T2 you can have 1 plus mg by ay under root. That root can be again further, you can take this as power half minus 1 minus 1 into minus c1, right? So 2 pi into del by j into, if you take this out, it will be 1 will be here minus 1. Now this can be expressed as, by using binomial approximation, we can write, you have to remember here, 1 plus x power n. Yep, this is reconnected back. Yes, I hope you now you're getting it. By using binomial approximation, we can say 1 plus x power n approximately equal to 1 plus nx. Here, whatever may be in this form, n or 1 by n or minus n or whatever, it will be multiplied here. So if it is 1 by n, 1 plus n by x by n, like that you will get. So this will become, what? Right. So this term can be expressed as 1 plus mg by 2 into ay. So you can further write it as 2 pi into square root of L by g into 1 plus mg by 2 into ay minus 1. Here this will simplify. If after simplifying this further, what will get mg by ay? This with out of root. Now you can understand what is this. Actually speaking, this is m effective m. That's what you have to consider here. Actually, this is m2, right? Yes, you can take this as, right. So it is nothing but 2 pi into square root of L by G into mg by 2 into ay. Here, what about ay and all in the options? If you observe here, okay. It is mentioned that the wire is having the diameter. Diameter is also given. That means area I can find out by using in terms of radius. You can express it. So it is equal to 2 pi into L is given. L G is known quantity constant. You can take it as M is given. You can take M into G by 2 into area can be taken as pi r square into Y is also given. After substituting all these parameters, you will get the change in time period. Change in time period is should be equal to 0.0035 seconds. 0.0035 seconds. You guys substitute these values and simplify. Substitute all the values and simplify, then you will get this, right? You guys do this simplification part. This is briefly about how to do this, you see. So knowing the concept is different, applying is different. That's what you can realize here. So we have discussed how to compare the elasticity with the springs, time period of the spring mass system and rod in terms of 2.2 time by k form. Here we are comparing this with a simple pendulum case. See, instead of simple pendulum, if spring mass system case is given, you should be able to understand how to do that just with the help of the idea of this concept. Okay, that's why concept you should have strongly a clear idea. That's why usually we used to spend more time in understanding concepts. Right, I hope you guys have done this. Do the simplification part by yourself, guys. Let's try it next. Let's see next question. Question number 24. Level 2 exercise to question number 24. A metal wire of 4 meter long and 2 into 10 power minus 7 square meter in cross section is stretched by a force of 30 Newton. If the work done in stretching that wire is 4.5 into 10 power minus 2 joule, the Young's modulus of the wire is. Right? How to do this? Yes, let us see next. Level 2 exercise 2 only. Level 2 exercise 2 question number 24. Question number 24. Right, guys. So what is given here? A metal wire 4 meter long. Length of the wire is 4 meter and 2 into 10 power minus 7 square meter in cross section. That is cross sectional area is 2 into 10 power minus 7 square meter means meter square. Square meter means meter square. cross section is stretched by a force of is stretched by a force of how much? 30 Newton. 30 Newton. If the work done in stretching that wire is 4.5 into 10 power minus 2 joule, work done is nothing but potential energy, of course, is equal to 4.5 into 10 to the power minus 2 joule. Then what should be the Young's modulus of the wire is the question. What should be the Young's modulus of the wire? Yes, directly let us try to understand this. Here work done means potential energy. We know that work done is equal to elastic potential energy is equal to half into stress. Remember this, then try to modify it to your required form. Half into stress into strain into volume, then convert into your required form. So what is the required form here now? Because length, area, force and work done are given, you are asked to find Young's modulus. Means you are supposed to relate work done or potential energy or strain energy with force and Young's modulus. Force means stress, force by area means stress and Young's modulus. So we have to modify this strain into a stress and Young's modulus relation. So it is equal to half into stress square by y into volume, right? This is equal to half into stress is force by area, f square by a square into y to volume is area into length. This on simplifying further, a gets cancelled, so we get is equal to half into f square l by what? A into y. So here f is the force applied is given, length is given, area is given, and y you are asked to find by giving the w, work done is given here. So you have to rewrite this form. So for calculating y, so this implies y is equal to f square l by 2a into w is equal to f 30 square. So 30 into 30, directly you can take it off, of course. 30 into 30 into l. L is how much? 4 meter. By a, area is how much? 2 into 10 power minus 7. Oh, already 2 is there. 2 into area is 2 into 10 to the power minus 7 into work done is 4.5. 4.5 into 10 to the power minus 2. So then what you will get? What you will get? So simplify this. 2 into 2, 4. 4, 4 cancel. 4.5. 4.5 is can write it as simplest form 9 by 2. While doing the calculations, you have to think about the simplification process, guys. You have to think. You should develop that by on your own way of doing a number of times simplified calculations. So you write that 30 into 30 is 900. 9 into 10 to the power 2 divided by 1 second, guys. Sir. క్లాస్లో ఉన్నాను సార్, ఏదో క్లాస్లో ఏమైనా ప్రాబ్లం ఉందని చేసినారే అనుకున్నాను. ఓకే 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 ఓకే. ఓకే సార్, షూర్ షూర్. ఓకే 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 సార్, నో ప్రాబ్లం. ఓకే ఓకే, నో ప్రాబ్లం నో ప్రాబ్లం. సరే, నేను క్లాస్లో ఉన్నాను, మంచి చేస్తాను. అయిపోయి ఒక 10 minutes, ఒక 10 or ఒక 30 minutes. Right, guys. Yes. So what will be after simplifying this? What you can write it as 4.5 can be written as 9 by 2 into 10 power minus 2. The 10 power minus 7 is there, so it can write it as 10 power minus 9. You can write. So here 9 cancel. This 2 goes to numerator, so it becomes 2 into 10 power minus 9. If it comes to numerator, it becomes 10 power plus 9. So plus 9 into 2, 2 becomes 10 to the power 11. So Young's modulus y is equal to 2 into 10 power 11. All are in SI units only, so it should be Newton per meter square or Pascal should be the unit of Young's modulus, and this will be the value. So is there such option 2 into 10 power 11? 2 into 10 power 11. Yes, option 1 is the right one. This is how you have to do it. That's it. That's it. Next, actually, I hope we have worked out a few questions based on Poisson's ratio. in this section also, in the previous session. Let us see here, based on whether you have done those questions or not. Poisson's ratio 17 and 18 are given in level 2 exercise 2. 17 and 18, you can cross check. You can cross check these two questions as well. The other questions based on what you call bulk modulus and rigidity modulus. These two concepts also are there for this weekend, right? So you guys have to go through this, and if you have any confusions, just drop me a message so that I can send the explanation part to you guys. Yes, copy it fast. Right, next let us see question number 18. Question number 18. Question number 18. Right. Question number 18. Level 2. Exercise 2. So it is given that the Poisson's ratio of a material is 0.4. Poisson's ratio symbol, you can take it out, sigma is equal to 0.4. If a force is applied to a wire of this material, then there is a decrease in cross-sectional area by 2%. Area, change in area is given. See what is that? Then there is a decrease of area of cross-sectional area by 2%. Means percentage change in area is given. Delta A by A into 100 is equal to 2 is given. Is equal to percent. And then there is a decrease in cross-sectional area by 2%. The percentage increase in its length is, then what is the percentage increase in its length? Delta L by L into 100. A percentage change in length is what? When area is decreased, obviously area, length has to increase. That is what you can understand. So for example, if you have a wire having length L and some cross-sectional area A, if you apply a force, if length increases, right, if length increases by small amount delta L, area should become thin, so area should decrease. So area is here, it is given that percentage decrease in area is mentioned. So the area is decreasing means length should increase. Otherwise, if you have a wire like this is a rigid support and this is a wire, your this is your wire, and force is acting like this. Its initial length is L. Now on applying this force, if length decreases, if length decreases by delta L, then area may slightly increase. So like vice versa, they're inversely proportional. You can say if length increases, area should decrease, and if length decreases, area should increase. This is called elongation, this is called compression. This kind of phenomena will take place in this. So that, to understand the meaning of this, I have given you this relation. Okay, now how to find this direct relation? You can use it. What is that, a direct relation? Right? We know from definition of Poisson's ratio, we know that sigma is equal to lateral strain by longitudinal strain. So only numerical value if you want. You write it as lateral strain is delta R by delta L by L. Let's say this is equation 1, and you are asked to find what do you call change in percentage change in length by giving change in area. Sigma is given. This is you are asked to find, but this is not directly given. Then how to find this is, as we know that we can take here. We know that as it is the radius is mentioned, you can take it as area. Area of circular cross section can be taken as pi r square. Then change in area can be taken as fractional change is delta A by A is equal to pi is a constant. You can take this out. Then change in r square can be taken as 2 into delta r by r. So from this you can be expressed as delta r by r is equal to delta A by 2. If delta r by r is not given, delta A by A is given. So in terms of delta A by A, how to express this way? So this implies delta r by r is equal to 1 by 2 into delta A by A. You have to take this, you substitute here, then you will get 1 implies sigma is equal to delta A by delta A by A half into, so half into delta A by A divided by delta L by L. So and this delta L A by A is given, sigma is given. It asks me to find delta L by L. Bring it here and bring this one down, then we'll get. So this implies delta L by L is equal to half into delta A by A into sigma. So or you can say into 1 by sigma. So it is equal to half into delta A by A. Percentage decrease value is percentage decrease in area is given. So from this you can also write it as just you also want to find what percentage increase in length, right? Multiply here into 100 into 100 both sides. Then we get this implies delta L by L into 100 both sides. If you multiply with 100, then we get half into delta A by A into 100, then you into 1 by sigma. This gives percentage change in area, but this gives percentage change in length. Now you can take this percentage change in length or increase in length is equal to half into percentage decrease in length is how much? 2 into 1 by sigma. Sigma is how much? Sigma is 0.4. 0.4. So this gets cancelled. So what you will get? What you will get is equal to this implies delta, and this implies delta L by L into 100 is equal to 1 by 0.4. So multiply this with 10 by 10, we'll get 1 by 4. 1 by 4 is 0.25, and in percentages you can say uh, what you can express, right? What you can express here, so 10 by 10, 1 by 4, 1 by 4 is 0.25 into 100, right? The numerical values are okay, zero point 0.4, zero point 0.4 or anything else, 0.04 or zero point 0.4 only. So change in area, percentage change in area is 2 only, right? Right. Right. On simplifying this, we can write it as um, yep. So if you multiply 10 by 10, we'll get, so 10 by 0.4 into 4 is how much? 4. So we'll get how much? 4 ones, 4 twos, 8.5. 4 fives, 20. So 22.5. So it is 2.5%. So delta L by L into 100 is equal to 2.5%. This is increase in percentage increase in length. So this is how we have just deal with this kind of questions, guys. So once you develop this way of doing it, you can work out any such kind of questions. As time up, I'm winding now. Okay then, guys, take care everyone. If you have any other questions or doubts, you can drop me a message. Let's take care everyone. Bye bye. Let me check once. Do you have anyone has dropped any message?